Hey, hello and welcome to today's GFG problem. The day hope you're doing well. So let's see today's problem. Search in a row matrix, row-wise sorted matrix. Okay. So what the problem is saying is we'll be given a row-wise sorted matrix because row-wise sorted matrix. What it means is that each row is sorted in itself. Okay. Okay. And what will be given is we will be given, for example, an element X. Okay, which we want to search in this matrix. And if the element is there, you want to return true, else you want to return false. Okay. So first of all, let's see what will be the naive approach. The naive approach is to search or is to iterate through each element, okay, and search and search whether this X is present or not. Okay. So this naive approach is going to take what? O of n into m, okay, which is almost like O of n square, right? So this is the naive approach. Okay, this is a naive approach because what we are doing is we'll be having to follow. What we are doing is we'll iterate through each element. We are going to compare with x. Okay, so let's see whether we have a better approach than this or not. Okay, so since what the problem is saying is we'll be given a matrix and each row is sorted. So we are going to make use of that particular property, right? So when it is sorted and you want to search an element, then what comes into mind? Okay, definitely it's binary search. So what we are going to do is we are going to iterate through each row. Okay, we are going to iterate through each row and we are going to search the element using binary search. Okay, okay. So I think let's go and code. I think you'll understand better. By this time I am sure that you must have what binary search algorithm is. Okay, so let's go and code. First of all, what we're going to do is, so before going to the code, I'll just request you please subscribe to the channel, like the video. Okay, let's first take the size of the row. Okay, the size of the row. Okay, so mat dot length we have taken here, right? So first I'll show the Java code followed by C++. Okay. And now what we're going to do is we are going to iterate through each row first, right? Definitely what we want to do is we want to iterate through each row I less than n plus I, right? And then what we are going to do, we are going to do binary search. We are going to run binary search on each row. Okay, on each row. And how it is going to be, for example, mat, we want to pass the row number as well and the element to be searched. Okay, if we find, for example, this search will return boolean variable, boolean value. Okay, if we find the element, then it is going to return true, else it is going to return false. If it returns true, then we want to return true from here itself, right? No need to check the further rows. If we didn't find, even after iterating all the rows, then we have to return false. Okay, so this is a code. Now let's write the main code, that is a search function. Okay, so what are we going to write? Boolean search. Okay, then we are going to have this mat, then int row number, we can say, and int the element which you want to search. Okay, now you know in binary search what we do, we take two variables, length, left and right. Okay, left and right. So left we start from 0 and right we start from the last element. Okay, from the last element. In this case, it is going to be the last element in this particular row number, so we want what? So for example, let's quickly int uh what do we want here? Call equal to mat of row number, right? We want to take the column size, right? Length minus one, we can say length minus one. Okay, and we are going to, so this will give the last element in the particular row number. Okay, now simply what we're going to do, we are going to run this while loop. This is a standard binary search algorithm. L is less than R, L is less than equal to R, then we are going to take a mid, which is going to be L plus R by 2, right? L plus R by 2. We'll see L plus R by 2. And then if mat of row number, right? If mat of row number, what we have done here is R is what? No, we have, so R should be this only, right? R should be this only. My bad. So we just want to take the position of the last element, right? The position of the last element in each row, right? That's what we are doing. Okay. And then what we are doing here is if row number, if mat of row number mid, if it equals to X, that is the element to be searched, then you have to return true, right? Let's quickly dry run. For example, this is the 1, 1, 2, 3, 4, and 5. We have this is one row. Okay, and what is our L and R? L and R is here, right? And for example, if you want to search for X equal to 4. We want to search an element 4. Okay. Now what is a mid? According to this is, so what are the indices? 0, 1, 2, 3, 4, right? 4. So what is a mid here? The mid is, the mid is mid equal to L plus R. L is 0, R is 4, right? Divided by 2, which is mid is 2. So mid is pointing here. Okay, now we're going to check here. Is add of mid, right? Add of mid, if it equals to the element to be searched. No, it is not. Okay, so if now it is not, right? So this is the first condition. So we are checking in that particular row, right? If it is not the case, then what we're going to do? We're going to check if row number mid, if it is less than the element to be searched, right? If it is less than the element to be searched, that means the element is on the right side, right? For example, here, this is the classic case here. So add of mid, this one, right? It is less than this x equal to 4. Then what are we going to do? That means the 4, the element is present on the right side of this 3, since this is being sorted, right? So that's what we're going to do. So L equal to, we're going to say mid plus 1, mid plus 1, right? Else, we're going to say R equal to mid minus 1. Okay, let's quickly check this. For example, so for example, this is less than X, right? So we're going to say L equal to mid plus 1. So L will be pointing here. Now what are we going to do? We're going to again find out the mid. So what is the mid here? Mid is, sorry, what is the mid? Now what will be the new mid? So 3 plus 4, right? So L is 3 now, plus 4. R is 4 divided by 2. 7 divided by 2, which is going to give us what? 3, right? So our mid is here now. 3, third position, right? Sorry, this is a mid position. This is a mid position. Now we are going to check, is R of mid equal to 4 equal to X? Yes, it is. That means we have found the element and we are going to return true. So that's what we are doing here, right? That's what we are doing here. We are searching in that particular row, the mid position, the element at the mid position. Okay, that's what we are doing. And for example, if we didn't find, if we come out of this while loop, we didn't, that means we didn't find the element, we are going to return false. Okay, so this is it. Let's quickly compile. So what the time complexity here it is going to be? It is going to be of n log n. First of all, let's see what is the error here. Expected I equal to 0. Where is it? Oh, my bad. Here we have written 2 times. Okay, let's compile this. So we'll see the time complexity here. So this, to search an element in a sorted array, the binary search takes log n, right? Log n. And again, what we're doing here is we are applying binary search on each row, on n rows. So it is the time complexity, it is going to be n log n. Okay, n log n. Okay, so the test is a pass. Let's quickly see the C++ code as well. So thanks for watching. Please don't forget to subscribe to the channel, like the video. Okay, let's quickly see the C++ code. So is a C++ code, not much difference here. The only thing is we are taking the size. There it was length, right? Rest everything is same. I think I'll attach the code in the description section so that it will be easy for you. Thanks for watching. Please don't forget to subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.